Sulfuric acid molecule.
The discovery of sulfuric acid can be traced back to ancient times, long before the scientific understanding of its chemical composition. The systematic study of sulfuric acid properties and composition began in the late 17th century and continued into 18th century. In the 17th century, alchemists and chemists worked on isolating and concentrating sulfuric acid from various naturally occurring sources, such as vitriol. The English chemist Joseph Priestley in the 18th century conducted experiments with various substances, including sulfuric acid.
Physical properties of acid sulfuric. In appearance, it's a thick, only and colorless to slightly yellow liquid. Not have a strong odor by itself. Chemical properties. It's a strong acid. It readily donates hydrogen ions when dissolved in water, making it highly corrosive. It's a powerful dehydrogen agent. It can remove water molecules for compounds.
Description of the chemical bond sulfuric acid. The sulfuric acid is a covalent compound. It is formed through the sharing of electrons between atoms, leading to the formation of covalent bonds. In the case of sulfuric acid, it is composed of covalent bonds between the constituent atoms, hydrogen and sulfur bonds. Sulfuric acid consists of two hydrogen atoms, H bonding to a sulfur atom, and two oxygen atoms, O. These bonds are covalent in nature, meaning the atoms share electrons to form stable molecules. Covalent bonds between hydrogen and sulfur. H hydrogen atom shares an electron with the sulfur atom, resulting in a covalent bond between hydrogen and sulfur. Covalent bonds between sulfur and oxygen. The sulfur atom also forms covalent bonds with the two oxygen atoms. Each oxygen atom shares electron with sulfur. Lewis structure. Step 1. Calculate the total number of the other electrons. Each of the oxygen atoms has 6 other electrons. One sulfur atom has 6 other electrons, and 2 hydrogen atoms have 2 other electrons. Therefore, there are a total of 32 other electrons. Step 2. Identify the central atom and write down all the other atoms around it, connected to it with a covalent bond. The central atom is sulfur. Write the hydrogen atoms bonding to 2 of the oxygens. Step 3. Place the remaining electrons into the dot structure in such a way that all atoms the molecular gate another gas configuration. We decided the central atom sulfur, the less electronegative of the molecule, and we place the oxygen atoms around it. Hydrogens are bound to 2 of these. The BSPR theory states the electron pairs, where there are bonding pairs or lone pairs, will arrange themselves in a way that minimizes electron-electron repulsion. This results in the molecular geometry of sulfuric acid being described as a tetrahedral. 2 lone pairs of electrons of sulfur occupy positions opposite each other, creating repulsion. The 4 sigma bonds are distributed in a tetrahedral arrangement around the sulfur atom. The repulsion between the lone pairs of electrons and the bonding pairs of electrons influences the bond angles and geometry of the molecule. In sulfuric acid, this leads to a tetrahedral shape with bond angles of approximately 109.5 degrees. So the BSPR theory helps explain the tetrahedral geometry of sulfuric acid by considering the repulsion between electron pairs in the valence shell of the central sulfuric atom. The valence bond theory helps explain the nature of the chemical bonds in sulfuric acid and provides insights into the structure and stability of the molecule. Hydrogen-sulfur bonds. In sulfuric acid, there are 2 hydrogen atoms bonding to the sulfur atom. Each hydrogen atom contributes 1 electron to form a sigma bond with sulfur. This means there are 2 sigma bonds formed between hydrogen and sulfur. Sulfur-oxygen bonds. There are also 2 oxygen atoms in sulfuric acid. The sulfuric atom forms sigma bonds with 2 of the oxygen atoms. The sulfur atoms' 3 p orbitals overlap with the oxygen atoms' p orbitals to form these sigma bonds. These sigma bonds result from the head-on overlap of the atomic orbitals. Double bonds with oxygen. In sulfuric acid, there are also 2 oxygen atoms that form double bonds with sulfur. These double bonds are the result of the overlap of oxygens on unhybridized p orbitals with the sulfur atoms on hybridized p orbitals. The pp overlap forms 2 p bonds. This results in a total of 4 sigma bonds and 2 p bonds in sulfuric acid.
Battery production. Sulfuric acid is a key component in the production of lead-acid batteries. Dye and pigment manufacturing. It is used in the production of dyes and pigment for textile and other materials. Fertilizer production. Sulfuric acid is used in the manufacturing of phosphate fertilizers like superphosphate and ammonium phosphate. Air pollution. Sulfuric acid production can release sulfur dioxide and nitrous oxide into the atmosphere, which are major contributors to air pollution. Sulfuric acid is a major component of acid rain, which can lead to the acidification of water, bodies, soil, and vegetation. Water pollution. Improper disposal of sulfuric acid or its byproducts can contaminate water sources, leading to water pollution.